In this video I'm comparing SDRs on a wire antenna at night to start with. The signal from the antenna is amplified and then it goes through this attenuator here and through a notch filter that has a deep notch just below 10 megahertz, about 75 decibels. Then the antenna signals go into this 3 dB hybrid. There is no resistor. The other input port goes to a signal generator from this cable, and the signal generator is set to deliver minus 100 dBm to all the SDRs. The two outputs from this hybrid, one goes here, a 3-port splitter, and the other goes to another 3-port splitter. And the 6 SDRs are RTL-SDR.com, 8-bit direct sampling, 2.4 megahertz sampling rate, the Airspy and the Spyverter combo, 12-bit, and it's an up converter, and then there is a tuner chip. So it has an issue with phase noise, perhaps. Then there is an SDRplay, and the things has the same architecture as the Spyverter Airspy combo, but it's inside a single chip, the MSI-001. And then there is a Funcube dongle, the Funcube Pro Plus, and it also uses the same chip as the SDRplay, the MSI-001. And then there is the Afedri NET. It has 2 channels, but I'm only looking at one of them in this study. And finally the Elad FDM-S1. All the radios are set for a noise figure of 25 dB. The Elad needs a 2 dB attenuator in front of it. The Afedri needs, what is it, 2.2 dB, 2.4 maybe, 2.4 I think. And the SDRplay has no attenuation, but the Funcube has an attenuation of 6 dB here. The RTL-SDR.com has 2 dB attenuation in front of it, and the Airspy has no attenuator on it. All the SDRs are set for best performance for narrowband reception. Let's start to look at the RTL-SDR.com. This instance of Linrod is looking at the audio, and it's set to show signal to noise ratio and with a scale that shows 0 when the noise figure is 25 dB. It's a special thing with this 8-bit converter. I turn on the antenna signal until we see a problem. Something like this. Well, maybe even less. Well, here is the point where there is significant interference. And I go back by 30 dB from here. 1, 2, 3. That's the point where I want to measure signal to noise ratio. Because if there is no other signal than the test signal, there could be artifacts because the noise is very low, maybe below the quantization noise. So I add the antenna signal as dithering to be sure that I measure signal to noise ratio properly. And you see it shows 0. So I can get rid of the antenna signal like that, and actually it doesn't make any difference. So I switch off the RTL-SDR.com and switch on this one, which is the Afedri NET. And then look at the noise figure, and you can see the yellow curve, it comes on 0, so it's the same noise figure. All the radios are set to produce the same bandwidth in this audio analyzing instance of Linrad. So away with this, and then I switch on here. This is the Elad FDM-S1, and it's also 0, as you can see. I switch that off and go here. Here is the Funcube. And it is very much the same. Maybe half a dB better. But the accuracy of this kind of measurement is not so good, so I don't worry about half a dB this time. Then we have the SDRplay. Switch on that. And it also shows 0, of course. And you can see all of them have the same bandwidth. And finally, the Airspy. Sorry. And it also shows 0. So they all have the same noise figure. For obvious reason, we suspect, of course, that the 8-bit RTL-SDR.com is going to saturate first. So I look at that first and step up the antenna signal level until there is a problem. And we have it here. And I'm looking for approximately 3 dB loss of performance. And I have to look for a while because the antenna signal varies with time. A little bit more than this. That's 10 dB, that's too much, of course. And you can hear problems come and go. So I have to make some kind of decision. I back off 2 dB from this. And I can take this as the limit for the RTL-SDR.com. You see, now it's close to 0, but interference was much stronger very recently. I can wait a little bit more. And, well, I give it more signal, like that. And it was some unusual strong signal, so maybe 2 more dB. I can look here while checking the other radios, because I can see on the waterfall in the baseband whether there is interference or not in the RTL-SDR.com. So I can go back here and check now and then if the signal level on the HF bands, well, also the medium wave, if they have changed significantly. But this is a reasonable limit, I think. For that I need to set the attenuator to 64 dB. Then I go for the next unit, and that is probably the Funcube dongle. So I bring up the signal 10, 20, 30, and of course I have to turn on the loudspeaker. $10 dB more, and you can see very clearly now where the notch is. And it's obvious we have a degradation that is significant. So I turn down the antenna signal. Seems to be something like this. And I read 28 dB. And I go for the next one. Presumably that would be the SDRplay, I don't know. Here is the SDRplay, and it's actually even more disturbed than the Funcube. So I reduce the level. Well, the Funcube and the SDRplay use the same tuner chip. So they should be similar. So I get the SDRplay at something like 31 dB. And here is the Airspy. It's a little bit better, but not 10 dB. There seems to be a sharper threshold. I'm back off 1 dB. So I get the Airspy at an attenuator setting of 24 dB. And then we have the NET Afedri. I switch that on, and I switch off the Airspy. So now it's the NET Afedri only, and it's similar to the Airspy, although it has a different characteristic. You can hear the clicking things. The Afedri doesn't have any filters, so it's sampling from more or less DC up to 30 megahertz or something, although the notch filter has an upper cutoff at about 13 megahertz, so the signals are limited. I turned on 2 more dB, and that's a disaster to the NET Afedri. And now I'm back at the level of the Airspy, but at this moment the interference levels are higher. And now they're lower again. But it seems, I would say, the Airspy is a little bit better than the NET Afedri in this test, because of the strong signals that are present on medium waves probably. The attenuator setting is 46 dB. And then I switch off the Afedri. And finally, here is the Elad FDM-S1. And it needs more signal. And it's also a wideband sampler, so it has this different characteristic as compared to those ones that have tuners. I back off 1 dB and place the Elad at, what is this, 21 dB on the attenuator. These are the results so far. It's now midnight, about 1 hour later, and I have set 64 dB on the attenuator and selected the RTL-SDR.com dongle. This one. And here is what I see on the signal to noise evaluation. And it looks reasonable. Occasionally it's good, occasionally it is bad, but an average 3 dB is not too far from this. So I think that hasn't changed very much. I go for the Funcube, that's 28 dB. 28. And then I deselect the, where is it? Here is it? This thing. And enable the Funcube dongle. And look at the S/N measurement. And this has changed. I wait a little bit. Then I bring up the signal level a little. And of course I do this second measurement because what comes from the antenna changes with time. At this time it seems that it is more favorable for the Funcube. And for this result, the attenuator reading is 21 dB. The next is the SDRplay. It was 31 before, and probably it is not anymore. The SDRplay, it is here. And I look at the S meter, and I have to back off a little. Well, a bit more. The relation between the Funcube and the SDRplay has changed a bit. They are different, although they use the same chip, the same tuner chip. The SDRplay seems to need about this level, and that is 27 dB on this attenuator. And the next is the Airspy, so silence that and enable the Airspy. And the Airspy before wanted 24. It's now 20. That could be a little bit too much. $21 seems to be what I need here. This is the result for 21 dB. The Afedri, I switch off the Airspy and enable the NET Afedri here. And it's not happy at all with this. I have to reduce the level. Something like this, and I read 23 dB. And finally the FDM-S1. So get away, get rid of the Afedri and FDM-S1 here, and it needs more signal to get problem. This isn't really fair to the radio. I should change the AGC properties. Release 0 and hold 0. Because those impulses that come occasionally are not really harmful, as you can hear now. So the level that we can send into the FDM-S1 it's something like this, and that is, what is it, 16 on the attenuator. And I go back to the NET Afedri here, and then change the AGC parameters also here. Well, attack 2 is fine, but release 0 and hold 0. And then I increase the signal level until there is a problem. And you can see on the white track that it's more stable now. And here is the point where there is less than 3 dB degradation, and that is 20 dB on this attenuator. Here is the result of the 2 sets of nighttime comparisons. They do differ, but not terribly much. It's only the RTL-SDR.com that differs by 5 dB from here to here. The other ones are pretty similar. So the average from these 2 columns here and here should give a reasonably reliable characterization of these SDRs when used on a wire antenna at night in Europe. It's now 1 o'clock, so the medium waves should be silent, and I will test the properties of these SDRs under daytime conditions. Starting with the RTL-SDR.com here. And the antenna signal is a little too strong, so I reduce it. And it takes some time before I decide whether this is the right level or not. I want the average to be around 3 dB, and it's something like this. Maybe a little less. I have to go a 10 dB step and then go back. So this would be the performance of the RTL-SDR.com dongle. And the attenuator is now at 74 dB. And then I go for the Funcube, switch off that, and switch on the Funcube here, and it can take much more signal, so I increase the level. So here is 2 dB loss. I have to go up 10 dB and then back off. Here's 3 dB loss with the Funcube, and that is at 37 dB. And then I check the SDRplay. It is fairly similar. dB more. So that's 35 dB. And then the Airspy. It has drifted in frequency, it seems. Like that. And it can take more. But not as much as this. Well, there is a sharp point, just 1 dB between here and here. dB more, and it looks like much more degradation than 3 dB, and back 1 dB, and then it's not so much disturbed anymore. So this means the Airspy is at 32. And then the NET Afedri. So 1 dB more than this was a little bit too much. So here I read 16 dB. And finally, the Elad FDM-S1. And it looks fairly similar to the Afedri. I give it 1 more dB. So it's not so critical. 1 more. There are different mechanisms. So the sharpness of where interference becomes strong varies between the different SDRs. But this is the level for the FDM-S1. And that is 11 dB. I repeat about 1 hour later. Here is the RTL-SDR.com. Screen looks like this. And the attenuator setting is 68. And here is the Funcube. And the screen looks like this. And the attenuator is 34. Here is the SDRplay. It looks like this. Probably there is reciprocal mixing from this strong station here, or maybe some more, because the characteristics of the noise increase is fairly different from what we see in the previous SDRs. The attenuator setting is 35. Here is the Airspy, and I add just 1 more dB. Well, 2 more dBs. And then it comes into clipping on the ADC. So I have to go back at least 1 dB. And this isn't really good enough, so I go back 1 more dB. And this is what it looks like. The IF filter in the Airspy is a little bit wider than the IF filter of the SDRplay and the Funcube. It's 0.5 megahertz, I think, and the other ones is 200 kilohertz. The attenuator setting is 32 dB. Here is the Afedri NET, and it looks like this, and you can see very clearly where the notch is here. And the attenuator needed for it to work is 16 dB. And here is the FDM-S1, looking like this on the screen. And the attenuator setting is 15 dB. Here is the result of the study today. Results differ a little bit, up to 10 dB from here to here, as compared to the best one, which is the FDM-S1. The NET Afedri differs by a single dB at 2 o'clock, but by 5 dB at 1 o'clock. Of course, the stations vary in amplitude, and stations come and go during the day. And generally the difference from here to here is not very big, but it is significant. So don't expect this to be a precise ordering, but you have seen when you come to this point the video and can make your own judgment on how bad the interference is when I selected what gain, or sorry, when I selected how much attenuation each SDR needs. Here is a spreadsheet showing the evaluations so far. The different radios here, the numbers here from 1 up to 4 is in which video two radios are compared. Number 4 is the current one. So in this one, for example, the Airspy+Spyverter is compared to the Afedri NET. And there are other occurrences of 4, of course. The other files are these ones. And I will put 4 here when I know where this video is going. And then there is the list here with the results so far. The FT1000 is the best one, nighttime. And then it goes all the way down to RTL-SDR.com, the 8-bit toy, which isn't really useless, but of course it has limitations. Putting a pre-selector in front of it makes it very much better.